Hello everyone, my name is Vishwa Patel and I am from Marwadi University in degree semester 3, and today the topic of my presentation is digital to analog conversion, which is guided by Professor C.D. Parmar. The content of my presentation is Introduction to DAC, definitions, use of DAC, conversion techniques, advantages and disadvantages, images, simulations, and reference links. DAC. What is DAC? DAC is a process by which digital signals are converted into analog signals. Digital signals are sent to a digital to analog converter, and the output of it is an analog output. Like DACs take a signal and turns it into an analog current, analog voltage or current. Definitions. A digital signal is a signal that is being used to represent data as a sequence of discrete values at any given time. It means that it can only take values at a certain point of time. And at any given time, it can only take one of finite numbers of values. An analog signal is a continuous signal for which time-varying feature of an analog of a signal is representation of some other varying quantity. It works on continuous data, and an analog signal can be either periodic or non-periodic. The use of DAC. The use of DAC is that it translates digitally stored information like from a laptop or any other such devices into an analog form. Use of DAC. DAC is a device that translates digitally stored information from a laptop or any other device into an analog form. A sine wave is defined by three characteristics: amplitude, frequency, and phase. If we vary any one of these, then we create a different version of that wave. So the wave will be in a different version if we change either the amplitude or the frequency or the phase. So by changing any one of the frequency of a simple electric signal, we can use it to represent digital data. This is an example of an analog signal. It is a sine wave, as you can see. And this is an example of a digital wave. Conversion techniques. There are three types of conversion techniques: amplitude shift keying, frequency shift keying, and phase shift keying. Amplitude shift keying. Amplitude shift keying is a technique in which the carrier signal is analog and the data to be modulated is digital. This is a type of conversion in which the amplitude of the signal is varied or modified to reflect the binary data. It means that the amplitude goes through some changes to produce the binary data. The binary signal, when modulated, gives a zero value when the binary data represents 0, while it gives the carrier output when data is 1. The frequency and phase of the carrier signal remains constant. As you can see in the figure, when digital data signal is 1, the carrier as you can see in the figure, when the As you can see in the figure, When the digital data is 1, the carrier wave amplitude remains the same over here. But as soon as it turns to 0, the carrier wave signal is much weaker. As you can see in the image, when the digital signal is 1, then the carrier wave amplitude remains constant. But when it turns to 0, the amplitude gets much weaker and it decreases almost by half. As you can see over here, the amplitude is 1, and as soon as it goes to 0, it decreases by half. So it is half over here. Advantages and disadvantages of ASK. Advantages are that it can be used to transmit digital data over optical fiber. It means that data can be sent over an optical fiber. The receiver and transmitter have a simple design, which makes it comparatively inexpensive. It means that it is less expensive compared to others. It uses lesser bandwidth compared to FSK, and it offers high bandwidth efficiency. The disadvantages of ASK is that it is more prone to noise interference and entire transmission could be lost due to this. And it has a low power efficiency. As you can see, this is an ASK circuit simulation which I have done in Multisim. As you can see, this is an ASK circuit simulation which I have created in Multisim software. I have connected the oscillators to different registers and capacitors and the multimeter, as you can see in the figure. This is the output simulated from the above circuit. You can see when the digital signal is 1, the amplitude remains constant. But as soon as it turns to 0, the amplitude decreases by almost half. This is the live video of the simulation output. Next is frequency shift keying. In this modulation, the frequency of analog signal is reflected. When binary data signal is 1, the frequency of the carrier signal is high. The output of the frequency shift keying modulated wave is high in frequency for binary high input and it is low for frequency in binary low input. The amplitude and the phase of the signal of the carrier signal remain constant in this. As you can see in the figure, when binary digital signal is 1, the frequency remains constant, and when the binary signal changes to 0, the frequency decreases by almost half. As you can see, there is a difference in frequency over here, and it is almost half of the number of frequencies over here. Advantages and disadvantages of FSK. Advantages of frequency shift keying is that it is modulated signal which can avoid noise problems that is set by ASK. In ASK, it is more prone to noise, but in frequency shift keying, it avoids the noise problems. It has lower chances of an error. It produces high signal to noise ratio. And the transmitter and receiver implementations are simple for low data rate applications. The disadvantages of FSK is that it uses larger bandwidth compared to ASK, and it offers less bandwidth efficiency, and it has low power efficiency. This is the FSK circuit simulation that I have done in Multisim. This is the FSK Circuit Simulation that I have done using multisim software. As you can see, I have connected the This is the FSK Circuit Simulation that I have created in multisim software. As you can see, the oscillator is connected to different registers and capacitors, as mentioned. As mentioned, this is the output simulation for FSK using the circuit shown. This is the live video of the output of simulation of FSK. Next is phase shift keying. In this modulation, the phase of the analog carrier signal is modified to reflect binary data. This is a type of conversion technique in which the phase will be modified. The amplitude and frequency of the carrier signal remains constant. As you can see in this figure, when voltage is 1, the carrier signal remains the same. But as soon as the as soon as the binary value changes from 1 to 0, the phase of the signal changes. First, it is in this. As you can see in the figure below, when the binary value is 1, the signal remains constant. But as soon as it turns from 1 to 0, the phase of the signal changes, as you can see over here. And next, when it turns from 0 to 1, it will again change its phase. Advantages and disadvantages of PSK. Advantages of PSK is that it is more power efficient modulation technique compared to ASK and FSK. It has low chances of an error, and it allows data to be carried along communication signal much more efficiently compared to FSK. The disadvantages of PSK is that it offers low bandwidth efficiency. The detection and recovery algorithms of binary data is very complex, and it is a non-coherent reference signal. This is the PSK circuit simulation created in multisim. This is the output simulation of the circuit shown. And this is the live video. As you can see, the phase changes when the digital value changes from 0 to 1. The reference that I have used is from the book called Data and Communication Networking. Thank you.